Hello everyone, welcome back to another video. Today we're going to be looking at the Doppler effect. Questions from this quite old paper. I think it's 2013. Question number 6 reads, the siren of a stationary ambulance emits a sound wave at frequency 850 Hz. So what we should do is highlight that and label that as Fs. That's the frequency of the source. An observer traveling in a car at a constant speed in a straight line begins measuring the frequency of the sound waves emitted by the siren when he is a distance x from the ambulance. The observer continues measuring the frequency as he approaches, passes, and moves away from the ambulance. The results obtained are shown in the graph below. So let's sketch a small diagram here. So we have a person in a car. Doesn't matter, right? The car. So there's a car, and then there is an ambulance. And the ambulance is stationary. And what's happening is the person approaches the ambulance and then passes the ambulance. So at some time, the person is now past the ambulance. Okay? So as the person is approaching, there is a perceived frequency, or there's an apparent change in the frequency, and then as the person passes the ambulance, there is another change in the frequency. So 6.1 reads, the observed frequency suddenly changes at t equals 6. Give a reason for the sudden change. So let's understand what's going on here. Remember, the frequency of the source is 850. From 0 to 6 seconds, the frequency that is heard is 900 Hz. And since it's greater, right? So let's say from T0 to T6. Since the frequency that's listened or heard is greater than the frequency of the source, we can say that the car is approaching. The ambulance. And then from T6 onward, the car passes, or you could say moves away. And why are we saying that it moves away? Because if you look at the frequency that's heard, the frequency is now 800. The frequency that's listened is less than the frequency of the source. So that tells us that it's moving away. That's why there's a change. Question 6.2.1, calculate the speed of the car. Take the speed of sound in air as 340 meters per second. Okay, so let's write down the information that we know. So question 6.2.1. We know the frequency of the source is 850 Hz. We also know the frequency that listened if we're using the approaching values. You could use the moving away. Let me just neaten this up. The frequency that's listened is 900 Hz. They also tell us that V is 340. And that's all we need. So we can use our formula. FL equals V plus minus VL over V plus minus VS times Fs. Now remember, we are using the values when the car is approaching. Okay, now I've said in videos before that when the car is approaching, or when the distance between the two objects is getting smaller, then we use a plus on the numerator and we use a minus in the denominator. Now let's substitute. FL is 900, V is 340, then VL is, the listener is actually moving, so we want to work out VL, and the source is stationary. Let's make sure. Siren, distance X from the stationary ambulance, correct. So source is stationary, and then multiplied by 850. So now we only have one unknown, which is VL, which is what we want, and we can solve. And when we solve for VL, we'll get VL equals 20 meters per second. Okay. 6.2.2, calculate the distance x between the car and the ambulance when the observer begins measuring the frequency. Now, it's quite rare that you'll find a question like this using equations of motion and so on, but as you can see, it can be asked. So we need to think about what quantities they want, what quantities we have, and then which equation of motion we need to use. So remember, they want delta x. All right, so let's redraw the sketch. So we have this car. Okay, and then we have this ambulance. Okay, weird looking ambulance, but that's what it is. And we know that it takes 6 seconds for the car to reach the ambulance. Okay, we said this before, because it is at this point here, at 6 seconds, where the car reaches the ambulance. Because here is approaching it, and here is moving away from it. So at 6 seconds, he reaches it. So we know delta t is 6. So let's write out our quantities. So question 6.2.2, we know delta t is 6. Okay, we know the car is moving at 20 meters per second. We worked that out. So V equals 20 meters per second. Now let's read this carefully, and we can find one more quantity. They tell us that an observer traveling in a car at constant speed. So in other words, VF is also going to be 20, or we could say A is going to be 0. So we have more than enough quantities to work out the value for x. So let's go with A equals 0, because remember, constant speed, meaning velocity is not changing, acceleration is going to be 0. So if we want to work out x, we can use the formula delta x equals vi delta t plus half a delta t squared. Vi is 20, delta t is 6, and then this whole thing becomes 0 because a is 0. That means delta x is equal to 20 times 6 is 120 meters. That's our answer. Now, if you'd like me to do more questions like this, let me know down in the comment section below. If you like this video, please consider leaving a like and subscribing and sharing. Until the next one, bye-bye.